Hello, we are just finishing up our videos on mixture and solution. This will be the last thing before we take our assessment for it. We're going to have a review and we'll probably take the assessment on mixtures and solutions on Tuesday when we get back. But here are the two videos that I want us to watch.
Have you ever poured chocolate syrup into milk? This is called a mixture. A mixture is a combination of two or more substances in which only physical changes occur. When this happens, no new substance is formed. Mixtures can be combinations of solids, liquids, and gases. Mixtures are either heterogeneous with unevenly distributed materials, like sand.
Remember, heterogeneous, that means it's uneven. It's like trail mix. It's like sand.
And trail mix. Or homogeneous, with materials that are evenly distributed all the way down to the microscopic level, like salt water. A solution is a homogeneous mixture that has physical properties from its ingredients. Think back to how milk changes color when you add the syrup. Solutions have one or more substances dissolved evenly into another substance. In some mixtures, the ingredients keep all their physical properties, making them easy to separate and sort. But in a solution, some physical properties result from a combination of parts. For example, if you add sugar to tea, it will become sweet, but the sugar will dissolve and become impossible to see. You can physically separate a mixture with sifting, settling, straining, filtering, evaporating, and using magnets. Whether it's for food or fun, it's good to be able to tell when something is a mixture and what that might mean to its physical properties.
All right. And then we're going to quickly jump to this one.
Check out what we made in class today. Tornadoes. It was easy. Want to guess what's in there? Let's give it some time to separate. What do you think this mixture's made of?
Well, I can see that there are two different liquids, but even though we mix them, they still say it's separate. So I'm thinking oil and water?
Yep. Oil is insoluble, which means it doesn't dissolve in water. Oil and water don't look any different when you mix them together.
You know, some mixtures are like that. Hey, what's that?
That's a mixture of some screws and nails from my garage.
Well, I could have told you that, Mr. Simpson, because when you mix screws and nails together, they're not going to change.
You're right. Let's start separating them so we can move on to the next mixture.
That'll take all day.
What if we use this magnet?
How did you know to pick the magnet?
And so that is a heterogeneous, right? It's easily separated.
When I bought the nails a while back, I noticed that the box they were in said iron nails. Iron, nickel, and cobalt are magnetic. And I'm guessing the screws must be made of something else because they're not attracted to the magnet.
So, the nails are magnetic, made of iron, and about 2 inches long. And when you mix them with the screws, nothing changed about the nails or the screws. I'd say this is a regular mixture.
I agree.
Okay, so what are you going to do next?
I want to try sand and water. Sand is tiny, gritty, brownish, and a solid, while water is clear and a liquid.
So I asked our students which one this would be, and a lot of them thought, oh, that's going to be a solution, Mr. Hazen, and they predicted a solution. Let's see how their prediction was.
It doesn't look like anything is happening, Mr. Simpson. The sand is just moving around the water.
Yeah, and when I stop stirring it, the sand just settles to the bottom.
This is also a regular mixture.
So their prediction was wrong, and they learned from their mistake, and they realized, oh, it is a mixture because it separates. It's easily separated.
It's like the ocean. The sand gets moved around the water, but it doesn't disappear in the water. Eventually, it settles to the bottom.
That's right. Both substances kept their properties. Now let's try mixing something else.
I have this water and I have these sugar cubes. Let's put them together.
With this mixture, it looks like the sugar cubes are gone. They've disappeared. Olivia, would you like to taste it?
It tastes sweet.
Great. That means that while the sugar is no longer visible, we know that it's definitely
So that would make it it's invisible, right? You can't tell. It is a solution.
still present because the water tastes sweet. This means that the sugar has the property of solubility. It can be dissolved.
So if the stuff we mix together stays the same and keeps our properties, then it's a regular mixture.
And if anything looks different about any ingredient that we mix, then it's a special mixture called a solution.
Now how are we going to separate the solution?
While we think about it, why don't you make a list of tools that you might use to separate the sugar from the water?
So a lot of our students said some of the tools that they could use was a strainer. They said to use a pan, which is actually really neat because that's what most of the things that they're going to show you here.
How about the strainer?
We can try it, but I don't think it'll work, Olivia. Remember, since the sugar dissolved, it'll probably just slip right through the strainer with the water.
Maybe. If we put this filter in the strainer, it'll help block the sugar. No, the sugar's still in the water. The filter paper didn't catch any sugar.
Wait, I've got an idea. If we add heat to the water, it'll turn into a gas. The gas will evaporate, then the sugar should be left behind in the pan. Now that the pan has cooled down and all the water's evaporated, look at all that stuff in the bottom. Olivia, would you like to taste?
It's sweet. We got our sugar back.
I'm excited that we figured out ways to separate almost every mixture we made today.
Me too, and I think I have the perfect challenge for us to tackle next. Well, we give it a shot, you might want to try it too. Mix 10 grams of sand with 10 grams of salt. Using the tools available in your science lab, see if you can separate the sand and the salt based on their properties.
Oh, I can't wait. This is going to be cool. See you next
time.